Hello, this is Real World Audio, and this is going to be epic. It's something that everyone has been looking forward to, a little comparison between active and passive phono stages. And so this question was asked of me, what do I think comparing these two? What are the benefits? What are the plus and minus for each of them? And I'm going to show you in a very, very simple and very close analogy. So I'm going to show you two phono stages, the schematics of them, and I will go through what does what inside the circuitry, and I'm going to tell you what are the benefits and the drawbacks of each of these designs. And I chose the as comparisons the ear 843p and as the active phono stage, and the Hagerman Cornet as the passive phono stage. And that's because they use basically the same vacuum tubes. They are both two stages, two 12AX7s for gain stage, and a cathode follower for both of them. So they have a very, very similar layout. And why did I start doing that? Because I had this video matching phono stages and cartridges, and I had a great comment from Gary, and he mentioned that he has an ear 834p. Sorry guys, I'm just really tired here. I can barely talk. I'm sleepwalking basically, but never mind. Uh, so and then I recall that guys, I have heard this phono stage at the beginning of my audio journey. Actually, I was thinking whether to build a clone of the ear or to build the Hagerman, and this is a debate that I faced something like almost 20 years ago. And I decided to go with the Hagerman because I prefer the sound of the Hagerman versus the ear. And because I had a friend who had the ear phono stage, so we listened it in his system. He was using 2A3 amplifiers with them, and we also had Jim demo his cornet in my mentor's Stu's shop, his audio store, Met Audio Directions. And so I had the opportunity to hear both and just decide what to build. And now I'm going to show you how I came to my conclusions, and also briefly share a little bit on how I perceived the sonic differences between the two phono stages. But without further ado, let's have a look at them. So when we look at the ear, it was reviewed in stereo file, so it's not an unknown phono stage, and I would rather say it's an epic phono stage. So Framer's review came out in 2005 about it, but it already references that it was already in 1996 it's been made. So even by that time it's been a decade that it was around, and guess what, even today you can still buy it. Now there's very, very few stereo products that have been in constant production for 25 years, and if anyone is doubtful about the sound quality of this phono stage, then that's a pretty good indication that there has been a constant demand through quarter century. And I'm going now to shed light on it, whether this demand is just some glorified aura of sentimentality, or does it have merit to it? So is it something that you should or could consider today? And just a little bit of thing, blah blah blah. You can read the review. I mean, Mike Framers But what I wanted to show here is that in 2005, the cost of this preamp phono stage was under $900, and if you look at its price today, I don't have it up here, but it's more than twice this number. So since then the costs have tremendously risen, and we are just keeping up with our time. So it's something where the value of this phono stage has not been declining as time goes by. It just gets more and more desirable, I would say. And if you think that the $2,000 plus price is a high tall order, but yes, this is what I'm talking about to you guys, that this phono stage and the cornet is really in this league, that they stand their prices in this sort of price category. And today the ear is in the 2000 plus range. But when we look at the Hagerman Cornet, so this is the schematics for it. Actually, this is the manual. So Jim provides manuals for all of his products, and all of the manuals include the schematics for everything. This is very, very rare. And even more rare, because I have seen some others publish partial schematics for their products, like I have seen some from AudioNote, although AudioNote does not publish any on their sites, but it looks like there are some schematics that are leaked onto the internet, and they seem to be authentic. Still, they are still floating around, but there are some companies who present their schematics, and then, as we found out, there was one very, very famous company, Bob Carver, and the schematics that he produces has some deliberate errors in it. So if you build the exact schematics, it won't work as Bob's amplifiers do. However, Jim's schematics that he provides are the exact schematics that he uses. So fair play to Jim. I have not seen this happen, and such honesty, such transparency is just unheard of in the audio industry. So as you see, this is an older version of the Cornet, so the current version looks much more modern and will be much more to your taste. His early looks for the early Cornet looked much more industrial, and he provided it in a kit version, so that's why it has this utilitarian looks, because it's a kit, and if you want to, you can build it in any chassis you want. So I built mine not in Jim's industrial looking cabinet, but I built a cabinet for myself for it. But the schematics and the transformers and everything is basically is the same. And let's see. Let's go for the parts for the schematics. And look, and the manual has detailed pictures on how it should look like, and in instructions. I'm just scrolling down to find the schematics. So this is where we started, right? And let's just rotate it so that we don't have to crane our necks. So here we go. So this is how the cornet is. We have 1, 2 gain stages and the cathode follower stage. And now let's go to the ear. I have found a forum at lancoheaven.net, and there is a poster, and look at that. There's a kit version of the ear 834, and look at that. You can, here it is, the person who posted it in this thread graciously showed pictures of his half-finished board, and there's the schematics for it. and and here we go. We see a very similar layout. We have 2 active stages and a cathode follower. The difference between them is that for the ear we have 12AX7 as the cathode follower, and for the cornet we have 12AU7 as the cathode follower. So what's the difference there? So both of them are the 12A7 family tubes. So essentially these 2 tubes are very similar. The only difference between them is that the 12AU7 has lower gain and also lower plate resistance. Plus, it is a higher current tube. So as such, it is much more suitable to be a cathode follower than the 12AX7. So using a tube as cathode follower here, this is a better choice because it provides much better current drive for your preamplifier. So here, this difference in choice between the tubes, it goes for the cornet. I mean the advantage part, because the 12AU7 will be able to provide higher current drive than the 12AX7. So me myself, I have tried both 12AU7 and 12AX7 as a cathode follower, and I can tell from experience that when you use the 12AX7 as a cathode follower, it's quite formidable and I really liked its sound, but it's quite thin and nervous compared to the 12AU7. So if you are contemplating to build a phono stage for your own and you want to put a cathode follower there, then I would recommend that you go for the 12AU7 because it will give you a more balanced, more neutral sound than the 12AX7. So so that's one thing. And the other thing that was the difference, but the commonality, is the 12AX7 tubes. So it means that basically we are looking at a quite similar sonic signature that you get from the vacuum tube selection between these 2 amplifiers. And also, even though there's a difference between the actual cathode follower tube, but these differences are not as big, being that we are talking about the same family of vacuum tubes, and thus mostly the difference that you get in the sonic signature between the cornet and the ear is because of the RIAA correction that they use. So basically the cornet uses a passive RIAA correction, which is found here. So here, this is your input, this is where the cartridge input comes in, and we have a 47 kilo ohm input resistor. That sets the input impedance. That's basically a grid leak resistor. And when you say that the phono stage's input is 47k kilo ohm, it means that it has a 47k resistor going to ground. And for example, if you want to tweak or optimize your phono stage, because let's say you read in your cartridge's description that it has wants to see a 27k input impedance or maybe a 60k, then change this resistor in your phono stage to the one that the cartridge manufacturer specifies, and then you will get the optimal sound. However, if you are unsure about the values, 47k is the standard that moving magnet cartridges use, and that's why basically every manufacturer uses that value there. So if you look at the ear, they also have a 47 kilo ohm resistor. Now you see, now here with the ear, the resistor goes directly to the grid of the input tube. And let's look at the cornet. There's a 220 ohm resistor. So what's that doing there? So this is a grid stopper resistor. So what it does is that it prevents high frequency oscillations from entering the vacuum tube, and that's because your cable, your phono cable, the interconnect you use for to hook up your turntable, it also acts as an antenna, and if it picks up any megahertz or gigahertz range oscillations, this grid stopper resistor, which actually goes right to the tube pin of the vacuum tube, it will stop those very high frequencies from being amplified and draining energy from the circuit. So this is always a very, very good choice. And I recommend it to use it in every vacuum tube amplifier. So there we go. This is like a minor difference, but you can do this to your ear as well. So especially if you have issues with high frequency noise in your area, then just put a 200 ohm resistor, something between 200 and 500 ohms. Anything will work there as long as it is connected directly to the tube sockets pin, and use as short lead as possible. And then as you see, there's no more grid stoppers on any of the tubes, so the ear design is much more susceptible for high frequency oscillations than the cornet. And here in the cornet you see the grid stopper is there for the second stage, and the grid stopper is there for the last stage as well. So that was, the grid stopper is actually a truly minor difference, but it can be big enough that by itself it will result in a much more stable operation and a more resilience against EMF, EMI, RFI problems. So now looking at the first stage. So this is the first stage that amplifies a signal coming from your cartridge. So basically we are dealing with a millivolt level signals. And here, we do not see it here on the schematics, but you can see here that the supply voltage for the plate load resistor is 300 volts. And actually the plate voltage is around 160 volts. Now let's have a look at the ear. And for the ear, it doesn't list here, but somewhere else it does list that the plate voltage is around 67 volts. So 2.5 times less plate voltage than with the cornet. And we have twice the plate load resistor. So we are basically running at a much lower current than the cornet is running the vacuum tube, and at a much diminished plate voltage. So it means that we are using very different operating points for this vacuum tube, and that also will give us quite a different sonic signature. One of the differences that we will see with this different operating point is that because now we are using a much lower plate voltage, the available resource for that vacuum tube, the dynamic headroom, is much less. So we have, let me see, I did some calculations here, blah, blah, blah. Where did I go? I did some little bit of, here we go, 7 dB less dynamic headroom with the ear because of the lower plate voltage compared to the cornet. And this will result in two things. So the ear will not sound as dynamic as the cornet, and also it will have a higher noise floor because the noise is riding higher in the dynamic range in comparison to the cornet's input tube level. And now uh, part of the active phonostage circuitry of the ear is to give you a better power delivery, better dynamics than the passive, but because the vacuum tube is run at a lower plate voltage, we are negating that advantage with this topology here. And now I'm at 20 minutes, so let's cut it, snip, 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 and we'll continue with the next video. Bye bye.